Science and Engineering at the University of California, Santa Cruz. He received his PhD from the University of Michigan. He is interested in open source, low-power computing, and EDA, including novel circuits, architectures, and software and model design tools. So let's welcome Matt.
So maybe I'll go under on time so we can get out of here and go to dinner. So this is even further from kind of the normal topic of ISPD. Lale and I were talking, so this is actually work by Lale and her student Gona, who's actually an NLP student doing natural language processing. And I've worked with them for the last 6 or 8 months since DAC last year on kind of an idea of just looking at the history of publications in our field. And kind of, we were originally talking about trying to do all of DAC, ICCAD, and all of the proceedings, but we ended up just focusing on ISPD because it's a more limited subset of publications, and it turns out to be a really hard problem to do this also. So I don't really have to talk about a history of ISPD. There's a lot of people that know more about it than me, but we know that there's kind of been some changes in what it's been about over the years. It used to be about kind of place and route, and it kind of went into a phase of like power optimization, and now we're seeing this tendency towards AI and things like that based on like Lydia was talking last. So why did we do this project? Well, we wanted to. There we go. Does that work? Okay, I can kind of join up the audience here. So, why do I want to do this? Well, we wanted to kind of look at the history of things because as we get older, we're always like, I kind of recognize this pattern of things that happened in the past happen again. We were basically trying to decide, can we recognize what might be going on in the future by looking at the past, essentially. And we want to look at kind of key breakthroughs and recurring challenges that we have in research. Which research has had the most impact and why? We also want to look at past trends and see what that reveals about the future. So we wanted this to focus not only for researchers, because we also want to know what's next, but also industry. They want to solve problems that they are going to be coming in the future, as well as just the ISPD community in general. And we basically looked at kind of 3 different things in terms of citation history of this conference. So we first looked at basically kind of topic identification, so looking at groups of different topics and how those have changed over time. And we looked at citation network, so who cited who, what papers became the most cited, most influential, kind of that type of thing. And as well, we did the geographical collaboration map, so kind of looking at how these topics change throughout the world over the last couple decades. And we used some tools to do this, and we came up with some, kind of interesting stuff. And so what did we start with? Well, we started with basically the ISPD data. We wanted to look at abstracts and titles of papers. We looked at author affiliations, where we were able to induce geolocation based off of that. Publication dates to talk about time. And then we just citations themselves, which can talk about which works influence other works. And then for analysis, we wanted to identify the major themes, see the impact through collaboration networks, and as well as kind of look at future directions. So what data do we use? We basically have over 700 papers from ISPD. It was really challenging to get a lot of this in a useful format. It's a lot of dirty data, and that removing this stuff from natural text results in problems of acronyms being defined and people's names mapping to multiple people and changing affiliations and all this stuff. We ended up going over a lot of this by hand, actually, to make sure it kind of looks right, which was kind of tedious. But we extracted all that information, and then we basically pre-processed the text, specifically like the abstracts, where we tokenized the abstracts and the titles. We looked at standard NLP things, where we removed stop words, we took stems of words, and we did lemmatization. Then we built directed graphs of the citation network, and we also geocoded the author affiliations. Now, there's been a lot of publications over the years. They've fluctuated a bit. You can see kind of the peaks back in the early 2000s, mid-2000s, some valleys during COVID. And I should note that these are mostly research papers. ISPD has a history of having a lot of invited papers and panels and things like that. But we found that those tended to either not have references, so they didn't really help with the citation index. And they also were, we just wanted to focus on the research topics themselves. Now, so we used BERT topic, which is a well-known technique in the NLP area to basically do a lot of this processing of the topics. And we basically pre-processed all of the titles, abstracts, and keywords, and we applied this to embeddings. And we basically found a set of kind of consistent topics that we saw in trends as well. And there were some also declining areas that we were surprised to see. We kind of point some of those out. So we wanted to use this to basically see the shift of this information over time. And we also looked at kind of different topic modeling methods. So this is BERT topic versus another LEA topic modeling. You can see here we basically specified 10 topic areas, and these are the STEM words related to those. There's 4 words categorized differently. And you can see, there's kind of words that obviously appear a lot in the ISP community, and the kind of grouping of them will roughly actually correspond to rough areas of research as well. Obviously there's overlap between these, and they're not perfectly defined, but these two different models kind of agreed as well, at least in the major groups, and so we were confident that was at least providing some consistent insight. Now, what does that mean for actual design? So if we look at just the BERT model, what we did was we looked at the 10 areas, the 10 of these model topics over time, and you can see the first one was actually kind of a catch-all. It was more of just design, and that didn't really focus on anything too specific, but the other ones really did kind of map to other areas that were pretty identifiable. For example, if you look at the second topic was placement, essentially, and you see that there's, in the upper right, there's basically placement papers throughout the entire conference. It's a consistent area of research and so on. Number 3, in the lower left there, you see machine learning. There's kind of this boom, about 8 or 10 years ago, where it suddenly overtook placement, or it's actually more common topic even. Surprisingly, there on number 4, you see a little bit of a decline in route, but I think that's because some of it's been engulfed into placement as well. We're now talking about placement while considering routing and stuff. And then you can see some other areas that are interesting because, for example, floor planning is interesting, where number 8, there hasn't been a paper on floor planning for quite a while. And that's presumably because a lot of this kind of got lumped into mixed mode placement. So they're not doing standard block-based floor planning anymore, right? And so it's no longer really a problem on its own. Unless maybe we get into chiplets. That might be kind of a new weird. We also saw kind of a decrease in clock design. There's been relatively few papers. This is mostly attributable to the contests. There were a number of contests a while back that resulted in a lot of the publications in kind of the 2010s. There hasn't been a lot since. And then we see some other areas. Interconnect has been a consistent problem as well, and then a little bit in kind of the power and analog stuff. So actually, I was going to skip over this. This is just a summary of the previous slide, kind of as a stacked bar graph. So we can see that topics evolved over time, but this next part we want to look at basically the citation map of who is working with who and how that's changed over time. And so we used another technique here where instead of doing the topic modeling based on the tokenization of the abstracts and titles, we looked at the references, and we used this to come up with clusters based on the Lupin algorithm there. And we also started looking at some other graph neural network clustering and so on, but we just went with this basic one to start with. And we built the citation graph. We basically grouped these into research clusters based on this. And these had their own sets of keywords that were different from the previous set. But we formed those and we examined how these grew over time. And then we applied this same sort of thing on each of those clusters and looked at the evolution. So what did this look like? Well, first we have the giant citation graph, which is kind of interesting. You know, we see a bunch of highly cited areas and so on, all the papers. This is every paper at ISP. This is not super readable, but at the end I'm actually going to give a link where you can go to this and you can look at it visually and zoom in and expand stuff and so on, which is actually quite interesting. And so you can see the highly cited papers in there. You can see some collaborative networks and so on. And then the colors in that correspond. They're not the same as the topic colors previously because these are the citation clusters, but we'll see what some of these are coming up. So we did kind of another time-based analysis here where you can look at like every 5 years. And you can see kind of in early 2000s ISPD, basically there was a lot of standard kind of place and route. This is the point tool era, right? You do placement, you do routing. There was some work on like Steiner tree estimation and wire length computation, that type of thing. Later in the late 2000s, 2005, 2009, this is when a lot of work on placement started coming up. There was more of the mixed mode placement type of thing that got a lot more interest. And eventually also started including routing and congestion and more complex metrics than the standard minimized wire length. And then we see in the early 2010s, it kind of went into, see the purple cluster of routing. That became a big topic. And as well as variability started popping up, that bottom area. So statistical timing and wire length, wire interconnect variation and so on. And then interestingly, the congestion and routing are kind of in the same 10-year period. You see on the lower left, 2015 to 2019, those are all congestion-related placement papers. And then, most recently, the ones that got the most, in this model at least, was advanced node stuff. And I surprisingly looked through all this and didn't see a lot of distinct machine learning stuff because the machine learning was actually embedded in all of these kind of categories. So it wasn't its own category like in the topic modeling, whereas it kind of permeated everything. So the last thing was we modeled the co-authorship, and we basically, this is the most challenging thing because, first of all, people move institutions all the time, and what you do with that. I learned about what the null island is. Does anyone know what that is? It's a point where you have the meridian and the equator right off the coast of New Guinea where it's 0, 0, longitude, latitude. We had a lot of bugs with people that were there for their authorship, which obviously wasn't true. We were wondering why there were a lot of African authors. So we kind of fixed a lot of these problems. I think we also had problems where if one of those authors was there, it would pull someone down. Like I think Chuck actually I think was publishing in Cuba for a while. And so we saw some of these things that we could fix the problems. But so we looked at this over time and kind of came up with some interesting plots here as well. And this one's also kind of hard to see statically, but there's kind of we're talking about how to even position this map because this is basically a U.S.-centric world map, right? Where we're in the center, but there's connections obviously to Asia that are moving that way over the last decades, Europe as well. We've seen that shift over time, so even how to position this map for a good visualization was kind of hard. We decided U.S. in the center because there's kind of a lot of connections both ways, made the most sense. But now, here's where you can open up the demo, and I don't know how I can do this without viewing it. So, we don't have a ton of time. people want to take a picture of that, they can go and click on it. I'll see if I can open it up too. Oh, is that one? Yeah. Oh, it opened over here. It takes a while to download it, but oh, this is behind my presentation over there, so that doesn't work. Yeah, I don't know how to do it. That one or this? That one? No, you can't see what you. I don't know what I did. So I can't see it. So. Oh, different tab. But anyways, you can see this that if you click on, you can change the time to pick the different time periods. You can also go in here to click the different collaboration networks. So that would go in here. You can actually go in and click on individual papers, for example, to see who cited who and so on. So yeah. So this is pretty interesting. And you can drag stuff around as well. And then if we go back, I don't know how to go back here without seeing it. I can't see anything. There. Go blind. And here's the world one as well, where there's actually some stuff on the plane. Here we could actually turn on and off things over here as well. And you can see the international collaborations and so on. So, let me go back to that other code. And basically, the conclusions here, I'll leave that here. We really need to focus on the contests. And I think that we found that the contests really do guide what happens for the next 3 years. I think there's been a lot of work. I'm not trying to be negative, but the contests have been awesome. And I think we need to think strategically as a group of people what contests we would want to have in the future to solve important problems. It seems like it's hard to get people to volunteer to do it because it's a ton of work, right? And so it ends up being what person wants to do it, it's kind of that area. We should kind of focus as a community and come up with which areas are the most important. I also found that if you looked at the one citation graph, a lot of ISPD papers don't cite other ISPD papers. We don't cite our own community. And that's actually a big problem. There were like a couple hundred papers that had no ISPD citations in it at all, or published in ISPD. So that's not very good, not to recognize the prior work in your community and so on. Working with dirty data is very hard. We're kind of used to it in the EDA area. Our data is actually relatively clean compared to a lot of different communities, but figuring that out is hard. And then we figured out, we still can't predict the future. But if you tell me what the next contest is, I can guarantee there'll be a lot of papers in that area next time. So, global routing. Yeah, so that's my entire talk.